Hello. Evaluate using indices. Let's do the first 16x to the fourth. And we're taking the square root. Whenever you see the index a half, that means the square root. And this is equal to square root 16 and also x to the fourth. Take a square root of 16, it's 4. And if we clear the brackets here by multiplying indices, we'll have x squared. So this evaluates to 4x squared. Next we have 4/9, and we take in the power of 3/2. Now we can write this as 4/9. Let's put in the brackets here. It's raised to half here, and then at the end, outer brackets, we have cube. When we clear this, we'll get back to 3/2. So first it's asking us to take the square root of 4/9, which means the square root of the numerator and the square root of the denominator. We get that result, we cube it. And this is equal to 2/3. And we cube the result, which gives us 8. 2 cube is 8 over 3 cube is 27. So that's our result. Now the last one, 2 raised to a -1 to the 4th power times 4 to the 3rd power of cubed. This is equal, we can write this as a half. And this is raised to the 4th power times 4 to the 3. That means 1 to the 4th power over 2 to the 4th power times 4 cubed. This is 1 to the 4th power is 1. And this becomes 1/16 times 4 to the 3rd power. From here, we can write that 4 squared is the same as 16. So we can rewrite this as 1/4 squared times 4 to the 3rd, so 4 cubed. The reason I'm trying, I use this as an equivalent to 16, because I'm looking for something with the same base as this 4 cubed, so that I can evaluate this without much of a calculation. Now I'll take this into the numerator, and now this becomes 4 raised to -2, and we're multiplying this by 4 cubed. We apply the law of indices, which indicates that we can add indices because the bases are the same. So this becomes 4 to -2 add 3, 4 to the 1, which is 4. So this evaluates to 4. Thanks for watching. I'm Alistair. Bye for now.